Hey everyone, so we're going to continue our discussion of exponential growth and decay. So we'll start right here. So in this first do now, what we're going to end up doing is they want us to convert each of these percents into decimal. So just trying to make sure that we all got that. Basically, one of the things that you're doing is taking the number, like the 13 in this example, and dividing by 100. That's the same thing as what I said last time, where I said to move the decimal place 2 times. So you can do one or the other, it doesn't really matter. This would end up being 0.13. This would be 1. This would be 0.04, 0.75, 0.29, 0.98, 0.007, and 0.525. All right. So this lesson is going to focus a little bit on pretty much the real world applications. The main applications that you're probably going to see exponential functions, you might even see it in real life, are things like compound interest, population growth, and if you go into science, anything with decay, like radioactive decay or bacterial growth, all work through exponential functions. This is actually one of the main reasons why typically if you're paying off a large loan, usually it takes a lot of time in the beginning to pay off the money. And then as you get near the end, it becomes a lot easier because there's compounding interest on that money. So the more money you take out on the loan, the more interest you have on it, and it gets really hard to kind of pay it all back. So just as a reminder, the exponential growth equation is modeled with this equation, and the exponential decay is modeled with this. Note that the main difference between these two equations is the plus being turned into a negative. And again, A is our initial value, R is the percent rate expressed as the decimal, Y is the final amount, and X is the number of, it says time intervals that pass. So if we're doing this based off of the number of years, X would be the number of years since it passed. If it was the number of months, we'd have to make sure it's the number of months. So going down to here, they just want us to label each one as growth or decay. So if you recall, before, if the number that's being raised to the power, if that number is greater than 1, that's growth. And if that number is less than 1, I don't know why I keep writing that 0. If it's less than 1, then it's decay. So going through these, this first one, that's bigger than 1, so this would be growth. That's bigger than 1, this is also growth. That's less than 1, that's decay. That number's less than 1, that's decay. That's greater than 1, so this is growth. And that's less than 1, this is decay. All right. So here, so the current population of the student center is 2,000. They want us to figure out the, it says that it increases at a rate. And they want us to find the year, the number of students after 3 years. So again, we do the same thing. We're using exponential growth. Our initial value is 2,000. Our rate is 4%, which is going to be rewritten in decimal form. That's 0.04. And the number of years is going to be 3. So just to kind of clean this up a bit, 1.04 to the third power. So going into our calculator, typing in 2,000 times 1.04 to the third power, and we get 2,249.728 Now it says they want us to approximate the student population. We cannot have a fraction, a decimal, a partial amount of students, however you want to call it. So we have to round this, and we're going to end up rounding it upwards. So the 9 becomes a 0 to round up, which means that this ends up becoming 250. So this is approximately the number of students that we have. Okay. Scrolling down. Here they say the word decreases, so this is going to be decay. And we're looking for the value after 5 years. So we're doing this. The initial value was 20,000. Our rate is 12% per year, so this is going to be written as 0.12. And it's for 5 years. So this is actually going to be rewritten as 1 minus 0.12, 0.88. So plugging this in, all right, we end up getting this, which if we're rounding it to the nearest cent, I'm going to round that number and I'm going to round it up. And the final value of the car will now be $10,554.62. All right. The next one. So they want us to figure out what the rate of growth is based off of this equation. So the rate is from in here. So that 1.02 is representing the 1 plus r that's in our sample equation. So subtract the 1 over, we get 0.02 equals r. As a percent, move the decimal place over 2 times, and we get 2% as our rate. All right. Here we have an equation that's representing the population. So they're saying that the population is representing in thousands. So this 20 doesn't mean 20 people, it means 20,000 people. And the T is representing years. So let's see, they want the initial population. It's going to be 20,000. They want to know the rate at which the population is growing. So just like before, this number that's raised to the exponent is representing 1 plus r. Subtract 1 from both sides. I get 0.15 equals r. Writing that as a percent becomes 15%. Because I'm just moving it 2 times over. All right, so the last one, it wants us to figure out what the population is going to be after in 2018. So, well, we're going from 2010 to 2018. So that's a passage of 8 years. So 20 times 1.15 to the 8th power. Putting that into the calculator. I get 61.18045725. Now remember, this is representing thousands. So the way I would write this to get to the nearest whole number, 61,180 people. Basically what I did was I just multiplied this by 1,000 and I got 6118 0.45725. And again, I'm rounding this number. Since the 4 on the right is less than 5, I don't change it, so I leave it as 0. And that's where I get the 61,180. All right, for this question, so this is something similar to what we just did. They want us to first figure out how many fish Jason had to start with. So this time, this is just representing the number of fish. So he started with 20 fish. They want us to know what's happening to the fish. So is this growth or decay? Since this number is less than 1, this is going to be decay. So what we would say is fish are dying. And this is because the value of B is less than 1. Here, it's an investment question. So they give us this equation, and they want us to figure out how much he'll end up making after 5 years. So all we're going to do is plug in a 5 in for T. Go to our calculator, do 1,000 times 0.7 to the 5th. And this will end up being 168.07. So essentially, he is starting to lose money, and he's losing money at a very fast rate. After 5 years, he'll barely have any money left. Okay. Moving down. So here's a multiple choice question. So we're going to actually just see which one makes the most sense. So they tell us that in 1984, we started off with 7 million households with computers. So our initial value is 7 million. The rate goes from 1984 to 1997. They said that that's 14%. And it says that it's growing. So it should look like this. They said that the households can be in millions. So instead of writing 7 million, I'm just going to put a 7 in for A. R in this case is going to be 0.14. So this is going to be 7 times 1.14 T. So instead of writing X, I could just write T to represent the years. So of these, the only one that matches is this one. Let's see. I think this should be the last one that we go over. So here they tell us that the population is decreasing. Actually, there's one more after this. The population is decreasing by 4%. So I use the decay equation. It started with 12,500 residents. The rate is 0.04. So plugging that in, 1 minus 0.04, 0.96. They want us to estimate after 10 years. So we're going to plug in 10 for X. So 12,500 times times 0.96 to the 10th power gets us 8310.40795. Obviously, we're going to round to the nearest whole number. So I'm rounding this. 4 is less than 5. So it's going to go all the way down to 8,310 people. All right, last one. Another car value question. So it deprecates or loses money at a rate, value at a rate of 5%. So we'll use the decay equation. Initial value is 18,000 at 0. The rate is 0.05. So doing this becomes 0.95. They said that they want it after 4 years. So I'm just going to replace this x with a 4 and plugging this in. I get 14661.1125. They don't say what they want it to, but since it's a money value, I'm going to round it to the nearest cent. So I'm going to round that second one, since it 2's to the right. It becomes 14,661.11. And that's it. So hopefully after this video and the last video, you have a stronger understanding of doing exponential functions. Again, if you have any follow-up questions, you can either rewatch the video or you can contact me, ask me for help. Thank you and have a great day.